the Gazaways. I'm Mrs. Gazaway.
I'm Mr. Blake.
And I'm Alyssa.
We're so glad you're joining us today. If this is your first time joining us, welcome to our channel as we explore science and do some investigations and have a lot of fun. If you're returning viewer, we hope you're excited for today's lesson.
Today we are going to be doing an experiment geared towards the younger kids, but the older kids might like it too. It's just geared for the younger kids because it's less mess and less materials. Okay, so as you know, science is everywhere. There is even so much science to learn with just balloons. So we're gonna air up our balloons.
Where are some other places that you think of science all around you?
Ooh, I'm out of breath. All right. And then we are going to put them against the table and launch them up. Woo, Mr. Blake.
So the air pushes out of the balloon against the table, also against the air itself, and the pull of gravity sending the balloon upward, or in our case, it went behind us just a little bit.
Something else that does something similar are rockets. Rockets work the same way. They use the ground, the air, and the pull of gravity to help launch.
However, balloons by themselves are not quite as effective as a rocket because they don't go straight up or they don't go in a straight path. There's lots of variables. As we said, ours went up and behind us. They can go in circles. They go all over the place. So they do use energy to help propel themselves, but it goes in all different directions. And so they expend a lot of energy. You saw I had my balloon relatively full, but it took a lot of energy to send it, and it didn't go very far away from us.
We're going to see if we can control the balloons. So we are going to be making balloon rockets. All right, so you only need 4 simple materials to make balloon rockets. You need some string, you need some straws, you need any kind of balloons. We're going to be testing different types of balloons today and different size balloons. And you need some tape. That is all you need for this activity.
So the first thing you're going to need to do is you're going to need to run the string or whatever you have available for your rocket track. So we've taken it just off camera from the edge of our carport and ran it down to a fence post down here. I did measure it to make sure it's relatively level, but you maybe don't need a track that long, but that's what we decided to do so that you'll be able to see it on camera here. Again, too, it's something that you can use whatever you have. If you have some string, great. If you have some fishing line, that's another great alternative. Whatever you have, you can make it work because that's the cool thing about our experiments is you can use whatever. If you have yarn, you could use yarn and make that work. Again, get parents' permission before you use any of it, but there's lots of different options and lots of things that you can use.
All right, so before you tie off one of the ends, you will need to attach your straw or put your straw on the string, just like we did here. Okay, so you're going to attach it on one side, then put your straw and then attach it to the other side. And then all you'll need to do is blow up a balloon and then tape it to your straw. When you blow up your balloon though, do not tie it because we need the air coming out of it so that it can launch our rocket.
And for our straw, we just use just a flexible straw, just like everybody finds at other places. If you, we also dug around. We found some jumbo straws too. We're not going to test these today, but that's another thing that you could do is try out if the different size straws sends it further, because these are a little bit, they're about half a time bigger than the other straws. If you had something like a coffee stirrer, that's another thing that you could try and see if that changes it, if that diameter of the straw changes how it works and how far it goes down your track.
All right, Alyssa said she has something to say. What did you want to say?
Will I not catch the balloon?
Yeah, you're going to launch them off. You're going to be our launcher.
But I want to catch some too.
You want to catch some too? Okay, you can launch them off and you can catch them. All right, so now Mr. Blake is going to blow up a 9-inch balloon, and then I will tape it to the bottom of our straw.
So we're going to use a 9-inch balloon. This is one of the most common balloons that you can find. When people say, hey, do you have a balloon? That's typically what you're going to find is a 9-inch balloon.
And he's going to blow it up as much as he can without popping it. So he can hopefully get all the 9 inches. And remember, do not tie it because we need the air to come out and push our straw.
So as we do this, we're trying to create as much force or as much thrust as we can. This is one of Newton's laws.
We will talk about Newton's laws at the end of our experiment.
And as we attach this to our track, we're going to put the opening where you blow it up, we're going to put that towards the camera because we want to shoot it this way. So that's where the air is going to escape and propel it forward, hopefully.
We're going to put the tape over the straw and onto the balloon. I might probably need a couple more pieces here.
All right, come here, Alyssa.
Alyssa, we need our assistant to help us launch the balloon. All right, you ready, assistant? All right.
Hold it up here. You ready?
Ready?
Okay, let's give a countdown. 3, 2, 1, go!
Whoa! Our balloon fell off, but our straw is still in place, so we will still be able to measure it. You can get the balloon, but don't mess with the straw, okay?
Daddy, which pocket did I put it in?
So we're going to measure this to get an idea of how far it went.
Mommy,
What?
I'm so happy I got the balloon.
Okay.
Okay, so this is 20 foot.
So next let's do this balloon.
Okay.
So it went 29 foot 7 inches. Stop wasting the tape. So I'm going to write it down so that I don't forget. So the 9-inch balloon went 29 foot and 7 inches. So that's actually quite a bit further than I thought it was going to go. What about you, Mrs. Gazaway?
Yeah, I went pretty far. Okay, so next we're going to do a smaller balloon. We're going to do the 7-inch balloon. So Mr. Blake's going to take a 7-inch balloon. I will go down and get the straw.
So my theory would be that this balloon, since it's only 7 inches, is going to go less distance than what the 9-inch one.
And as you can tell, we don't have a very controlled environment because the wind, we get wind gusts every now and then. But for the sake of our experiment, it's okay. All right. Remember, when he blows it up, he's just going to pinch it off and do not tie it. And then we're going to put tape on the top of the straw and then stick it to the balloon.
So your balloon might look something like that.
Okay, remember the ending of the balloon, the bottom of the balloon is facing the opposite side that you want the balloon to go, the opposite direction. More? It's about 3 pieces of tape.
And again, this is something that you could use whatever kind of tape you have. We just decided to use clear tape. If you had masking tape, if you had duct tape, whatever kind of tape you had, you could use.
All right, assistant, come launch the balloon. All right, she's coming.
Okay, so this is a 7-inch balloon.
Let's see how far a 7-inch
Okay,
balloon
we're going to
goes.
count down, all right?
All right,
3, 2, 1,
go!
My theory was way wrong.
So we went clear to the end of the post. So we're gonna see how far that is. So I think it could have even kept going if our string was even longer.
So how does that work? Because we had a smaller balloon, but it went further than the bigger balloon because we had the 9-inch and it went 29 feet and 7 inches, and that one was a 7-inch balloon and it went further. Any guesses on why that was?
Alright, so now we're going to measure and see how far it is to our fence post. I thought this was going to be way too long of an area, but I guess it's not. Because we need more area.
We might have to revisit this one in a future episode.
Mommy. Daddy's holding all my balloons.
20 foot. Okay, that's 40 foot. So that went 49 feet.
Alright, assistant is going to push the rocket back.
So that went a total of 49 feet.
Okay, right here. So I can load it. Alright, go get in position.
And as Mrs. Gazaway said, I think that could have went further had we had more track.
Alright, now we're going to use an even bigger balloon that is 12 inches. We'll use a pink one to make our assistant happy.
I'm not gonna make any guess on this one because I was way wrong last time.
So let's see what happens with the 12-inch balloon. So while he's doing that, I will get my 3 pieces of tape. I'm kind of starting to make them longer because you just have to get a feel for how big.
I like the pink.
Okay, and again, make sure that you pinch the bottom. Don't tie it off because we want the air to release, and that's how we power our rocket. That is a big one, huh? This is going to be super cool. I might need more tape for this one. All right.
Oh my. I did not know that would go this far.
If you can't believe how big this one is, you won't believe what we have coming up next.
I think it will go all the way into the
All right, so we'll bring it back here to the beginning.
All right, assistant, you ready?
All right, let's give a countdown. 3, 2, 1, go!
Oh, so I think it was too big and it fell off our straw. We're going to do that one again and maybe put some more tape. Science, you fail in science, and that's okay. So we're going to get another 12-inch balloon and put more tape and see if it'll stay on there.
All right, so we'll blow up another one and try it.
Mommy.
Go back to your position.
What?
So you might have to have an adult help you blow up these balloons because it may make you a little winded.
Maybe I'll do the next one.
I just found a worm in the water.
Okay, that's fine. Go back to your spot. All right, I'm going to try and put a lot more tape on it this time.
And Mrs. Gazaway is kind of creating an X with the tape. I think that's a good idea. So imagine if we were making real rockets and the balloon acts as our propulsion, so that could be our jet engine, and the straw is like where our astronauts, where our payload is. So imagine just like we had a, I would say complete failure there because our rocket engine broke off of our capsule. Imagine how this would be in real life if you're designing a rocket, of how much force it is to keep the payload and keep the capsule attached to the rockets.
Like I said, it's always okay to fail in science because you learn from your mistake. All right, let's launch this one.
Okay.
All right,
3, 2, 1, go. So it also went down to the end. However, that had a really delayed reaction. I don't know if you guys could see that on the camera, but that had a delayed reaction where it took just a little while before it actually started going down the track. So we know this is 49 feet.
Alright, and while he's doing that, we're going to use an even bigger balloon. I have a 17-inch balloon. Okay, so this might take a while to blow up. But we're going to blow this one up and see what happens.
Something too, as we do science, we got to make observations and stuff. And so I can tell you that an observation that I've made on this is it's probably not a bad idea when you blow your balloon up.
What's this for?
So when we blow our balloon up, we have the straw on top, so the track is above the balloon as we send it down. But we've seen several of them spiral around the string, around the track, and various things. So that also tells me too that if we were doing this, another variable we could change is think about adding some weight to the bottom of the balloon. Because the track's on top, so we could add some weight to the bottom so that it would try to keep that balloon down. Because again, if we had a way longer track and we were seeing exactly how far we could take this, that's something. Assistant, come back over here and quit doing that. That's something that we could potentially lose. Pick it up. We could potentially lose some of our force and some of our thrust, because it's spinning around the track, around the string, rather than going down the track, which is what we want.
All right, as I'm blowing up, just a second, I'll talk to you in just a second.
I want to play with that.
Okay, just a minute. All right, as I'm blowing this up, what I thought about is maybe another idea that we could have done is to time how long it took us to get from that point to this point. That would have been a really good experiment, because then we wouldn't have to have the string go as long. We could have just timed it and seen if it could get there quicker or take more time.
I think our assistant's getting tired.
This is real life science for you with a 4-year-old.
No, you can play with them after we're done shooting our video.
Alright, so this is our 17-inch balloon. We should have got some duct tape or something for this one.
Science is a great thing to do and then take a nap afterwards.
And like I said, it doesn't always work. We didn't think that it was going to go that far, but it's just something you have to test. One more just in case.
All right.
All right, assistant, do you want to launch this big balloon?
Then time to blow up
Over here.
again, then I can play with
When the video's over, I'll
So
blow it
this
up
one
again
is
so
our
you can
16-inch
blow it.
balloon.
I got something in my shoe real quick.
Okay, let's launch this. Come on.
All right, ready?
Let's give a countdown.
All right, countdown in 3, 2,
2,
1.
1.
Blast off! Did you see that it went the same distance, but did you see how much slower it was going? So I think maybe
That
during
was
the
so
time
cool,
would have been more effective, but that's okay. Something that we can learn for next time.
So that one also went 49 feet. And again, like I talked about, you guys really can't tell this on the video, but this balloon, it's heavier. Obviously, it's bigger than the other balloons we're using, but it's thicker, it's heavier, it feels heavier, which kind of elaborates on what I was saying just a little bit ago about giving some weight, because you noticed it went a lot of the way down the track before it started to kind of spiral and start losing some of its thrust to go forward, started wasting its thrust to go a different direction. So that's an interesting observation in that that it definitely did behave just a little bit different. But like I said, it definitely has a feel. It feels thicker and heavier. So we're going to use one of these clown balloons.
So says twister balloons, but I call them clown balloons too. Balloon animal.
Can you blow this one
Balloons.
up after the video?
Yep. All right, so we're gonna see how this one works.
Blow all the flames.
Okay, assistant, can you go get in your spot so that you can launch?
Poppy.
So, Mrs. Gazaway, where do you think we should tape this on at?
Probably in the middle. Or maybe towards this end. Let's do it towards this end.
So this could be another. This could be another variable that that you could try and see if it changes where you tape it on. Assistant, you need to go take a break.
All right, assistant, we need your help. All right, so let's see if this works. I taped it to the back of the balloon, so
Okay.
let's see what happens.
Okay, let's do a countdown. 3, 2, 1.
I think that went our shortest yet.
Take it off. Let's measure. So let's measure this one.
All right, and then we're gonna tape it in the middle and see what happens next. So,
This went a whopping 4 feet.
all right, I'll blow up another one, and we're gonna tape it in the middle and see if it's a difference.
Mommy.
And then after we tape it in the middle and see, then we're gonna try 2 of these balloons and see if we can get it to go.
Mommy. I'm putting all of my balloons in Daddy's pocket.
Okay, to keep them safe. Oh, look at this balloon! A wacky lid. Oh, the hair out here. All right, so let's try and tape this in the. And I just tied it. It's fine. I'm used to tying it. Remember, I said don't tie it. All right, let's try
There
this.
you go, assistant. You can play with that.
Okay, we're going to blow up another clown balloon, and then we're going to tape it in the middle and see what happens. Okay, make sure to pinch it and not tie it.
So something too that makes this difficult is this balloon has a curve.
Look,
to
I
it.
have
They're
a
not
new
straight.
balloon.
Alyssa, watch
Okay,
out.
can you please move out of the
Alyssa,
camera?
move out of the camera.
Alyssa. Okay, assistant, get in your position.
Okay, so this one is taped in the middle.
Okay, assistant,
Hang
you
on,
ready?
let
Can you hold my balloon?
Yep.
Don't count Guppy out me.
All right, let's give a
Ready?
countdown. 3, 2, 1.
Lava!
Oh, let's see how far this one went. This is when we taped it in the middle. So let's see.
So we'll measure this one and see where it's at.
Woo.
Mommy.
It went 17 feet.
Mommy. Can you tie this balloon to my finger?
So it went 17 feet when we taped it in the middle. So now we'll do one more and we'll tape it at the end and see at the other end. See if that changes it. As we said, we've got the wind that we're dealing with. That is a good reason
Watch out, come here.
why your assistant needs to pay attention, because that would hurt if it conked you in the head.
And look, Mommy tied my balloon to my hand. And look on the other side.
Alright, assistant.
She has her own experiment going on. All right, assistant, you ready?
So we're gonna tie this one at this end and see if it makes a difference.
Look, it's shaped like a T.
Assistant, go get ready.
Assistant, let's go.
Hopefully your assistants listen.
All right, ready?
All right, so we're gonna try this
She's
one.
4, she's fine.
Let's give a
3, 2, 1,
countdown.
blast off!
All right, you
All
gonna
right,
help
try
me?
again. Ready? 3, 2, 1,
1,
blast off! Whoa, I think that went farther. Let's see.
Put it in the pocket.
All right, 23 feet.
Measure me.
All right, can you bring it back? Can you bring the straw back?
Here.
So that one went 23 foot.
All right, and just for fun, we are going to try 2 of these balloons. So we will blow up 2 of them and see what happens. Okay,
Are you ready, sister?
It's okay, we can make another one. Alright, you better go inside and talk to Grandma. Go tell Grandma you got hurt.
Our assistant had a stumble on the ground. Are you gonna be okay? Okay.
My balloon,
We will make you a new one when we're done.
my balloon is popping.
Alright, so we're gonna try 2 of them, tape them together. We will try it in the middle. We'll put like one on this side, one on one side of the stroll, and one on the other side of the stroll. We'll see how this works. Not sure how this will work, but we'll make it work. Okay, assistant, I will make it. Assistant, you can have one of these, okay?
Subsequently, after you're done with these experiments, you can try to make balloon animals out of these balloons.
Make a balloon animal out of 2 balloons.
I do good just to get it blown up and it be a snake.
I kind of made her a wiener dog. I don't know if it's the best, but it worked.
Just run away.
No, it's inside.
It's inside.
Mommy, get 2 balloons and blow them up for me.
Assistant, come get over here, get ready to launch.
Okay, so we're gonna tape the bottom of these to tape them together.
Assistant, put those back and get ready to launch.
Alright, so we're gonna see what happens.
Blow these up.
Okay, launch and then I'll blow these up for you. She loves balloons if you can't tell.
3, 2, 1.
one.
Blast off.
Maybe it went a little bit shorter. Let's see.
Leave them on there, leave them on there, leave them on there. Alyssa, leave them on there.
Pop it.
Does Daddy have to collect all the balloons?
Did you blow them up for me?
So it went 16 feet.
Not yet, the video's almost over.
So that one went 16 foot with 2 of them. When we did it with just 1 balloon in the middle, it went 17 foot. So having a second balloon actually lost a foot of travel for us. So that's interesting.
Our data is very interesting and it's really fun to look at. Like I said, I think what would have worked better for us, and we learned, that's what you learn in science, we explored and we learned, is that we could have timed how long it took us. Because if you would have looked at them, some of them were really fast and some of them went a lot slower.
Right. And so that's something that we learned, as we thought our track was actually going to be way too long. In reality, it was way too short. So as Mrs. Gazaway said, that's a good way for us to change and use what we have. We could always make a longer track, but to use what we have and use our stopwatch to see how long it takes to get there, that's a good way to try this as well. So as we said, this actually uses 2 of Newton's 3 laws. It uses the second law, which is force equals mass times acceleration. So if you were bored and wanted to figure that out, you could use the formula F equals m times a. So force equals mass times acceleration. That's how we know our force. You also heard me referring to it as thrust. They're kind of interchangeable, where that's what it takes to propel our rocket, our balloon rocket, or a regular rocket up and get it into outer space.
We also use Newton's third law, which is for every action there is an equal and opposite reaction. So when we blew up the balloon, air came out one end and it went the other way, so that is an opposite reaction.
So we hope you guys had a lot of fun with us learning. As Mrs. Gazaway had mentioned, we're doing this in our backyard. We're having fun. We found out some really interesting information, and what our assumptions were and what our theories were actually quite incorrect. on what we were assuming and what we were thinking, but that's why we do science, is to learn and grow. We hope you have a lot of fun doing this project. Again, if you've enjoyed watching our video, watching any of our other videos, be sure and subscribe to our channel, like it, you can share it, talk about it, do all those fun things. We appreciate the support, and we appreciate you tuning in and bringing you some of these fun videos.
Until next time on Exploring Science with the Gazaways, bye!